Okay, let me go over the exercise for this week. We're talking about passive heating in the lecture, and so the exercise is about trying to manipulate heat both in our physical and our digital model. And so in the exercise assignment, these top two images represent the physical model outside. What you're doing here is you're configuring the model in a way based on what we've learned this week, what you just using your common sense also, that you think might allow you to maximize the delta T, the difference in temperature between the inside and the outside. So you may face it southeast, north, or west in terms of a facade that you have glazing on, you have an opening on. You may have openings on multiple facades or on one facade. You may have it on the roof, whatever you think. And I hope you'll try more than one configuration. And you're going to site your project outside and measure the temperature relative humidity inside and outside, and try to maximize the delta T while keeping track of the relative humidity. Okay, so that's the first thing. That's the physical model portion of the assignment. Then we're doing a digital model, and we do this every week, right? We're trying to create a sort of simplistic digital twin concept. So let's go to Rhino. And so here's my model inside. I've just, whatever I did outside, I'm going to try to emulate it inside. I'm not going to get measurements that are the same. I'm not concerned about that. Outside is very specific for a specific time and cloud cover and, whatever. This is going to be more general information. And we're specifically dealing in this model with the solar heat gain coefficient. So anyway, here we are. We've got our model. I'm using a cube. I'm just picking a very simple facade with a single window in it. And then I've configured it here to where I've got, let me go to a different view. So I've got a ground plane that it's sitting on, and I have four sides. Let me turn off my, this is the original model. I have materials on all sides. Doesn't really matter what this is. I mean, I'm just playing around with this. It doesn't matter. I mean, let's just go and change all these. I'm going to set them all for some kind of concrete. Doesn't matter right this minute. We're just, we're experimenting, right? So there's a bunch of concretes in here. For some reason, this one's not showing me exterior. That's just floors. Here's a concrete wall. Okay, select it. The ground, I've set it asphalt, whatever. What I ask you to do in the assignment is now run a series of radiation map simulations. So let's go to that workflow. This is the model I used last week, so I have a bunch of surfaces that I've already created. I don't need any of those on right now. I'll leave the ground on, but that's actually I won't even do that, because I just want these surfaces to be blocking or reflecting the sun. Now I'm saying let's just test the model initially. I'm going to go to a ghosted view. So the first, I'm asking you to run two simulations. One is by turning off the east window, or the east facade, not the window, just the full facade. So here, we're turning off the east facade, and we're running a simulation, and then we're turning off the south facade, and we're running a simulation. And so when I did that on this model, I have no east. Is this? Oh, and so if you were doing screenshots, you'd want to probably maybe go to a ghosted or a wireframe, keep the same shot. And I'm turning off the east now in the model, so that it so that what I'm seeing in the model is what was simulated. You may not have realized that yet, but what's in the graphics model in Climate Studio, in Rhino, is not necessarily what is in the simulation. In this case, we have to let the model know what we want to be interacting with the sun by giving it a material. So only things that have materials will either block or reflect the sun. They're going to do that based on their reflectance values. We talked about that in a whole week of the fundamentals. And then we create a work surface. Then if we go back to that, that's this. And in this case, my work surface is, I've got a whole other set of layers because let's just turn that on. Well, actually, I won't yet. I did create a let me turn off my simulation. I created a floor with sensors on it, and that's the only thing I'm going to have turned on. Like I said, I'm using the model from last week, so I've got all the surfaces I used in my radiation maps last week, and I have it set the sensor spacing at 1 foot. Remember, we're in the foots model. We've decided to scale up from inches to feet. Okay, so that's how I've configured my initial model runs, and I am getting these results. So the east first, east and south. I'll leave it to you to see if you get the same kind of results, and if so, how you would interpret that. So in this, like I'm saying, in the south, I turned off the south and turned on the east facade. I can set the range to whatever I want to down here that makes sense for understanding the full range of simulations I run. I can set the range of colors here to whatever I want it to be, to get a different feel for it. That's all subjective, but you want to create a color palette that's consistent and a range that's consistent so that we're comparing the colors across all simulations. Okay, so, and then the other thing I said is that I want us to not, so right now I just happen to be on indirect exposure. You should know what all three of these are. The total solar exposure is the global horizontal. Direct is we've talked about what direct normal is, and then indirect is what's bouncing off the clouds. In the instructions I say just to look at the direct solar exposure for this week. And you should look at the others to try to understand them, but that's what makes sense in terms of what we're trying to do. So, okay. Now so right now we've just run 2 simulations with just blank facades, right? So this one was run with this configuration. If I now, and so then in the assignment, what it says to do next, I'm going to just turn off the ground just so it'll be, I don't know, more graphically clear. I then configured my model as I had it outside, though I haven't actually done this outside, so it looks like this, right? It's just got the south facade has 1 window in it. And then I did a series of, I actually ran more simulations than I asked for. I did it without glazing, so without the glass in it. So let me go back to this. So I ran a simulation without glass, and then I put the glass in, and I have an SHGC of 0.9, and we see that I did get I got a change in the amount of irradiance, the direct solar irradiance on the floor in here. So let's remind ourselves what this HJC is. We talked about it in a lecture, but we got to always reinforce ourselves, right? So I'm going to the Climate Studio Materials tab. If I go into my glazing layer, that's the layer I have this window on, or this one piece of glass. I want to pick I'm sorry. If I click on any of these columns here, it will sort for those. And so I said I wanted something with a 90% solar heat gain coefficient of 0.9. Remember, the solar heat gain coefficient is the amount of solar heat that is going through the light as a ratio. So 100% of solar heat is hitting the glass, and then 90% in this case is going through it. So that's a high number. So I picked this one for my first one, and I ran it, and then I came back and I said I just wanted to reduce it for twice. So I chose a different set of glazing. Remember, you have to come to, I'm just going through this quickly. We've already gone over this. You can ask questions. I'm in the glazing materials. By the way, always turn off shading. I don't know if it's going to affect this. That's a daylighting setting, but let's just make sure we turn it off. I want to make this as clean as possible. And then I would pick something else that has a lower solar heat gain coefficient and run it. So in this case it's 60, and then I'd run it again with something much lower. And so I'd have a comparison of 3 different runs. I would notate what they are, what their solar heat gain coefficients are. And then now I have, let's go back to the assignment, which is where I put it. Oh, there it is. Okay. So I've described both of these actions. Then I ask you to bring this all together in a spreadsheet. And so we need the outdoor temperature, relative humidity for all the different situations. The time of day would probably be good. Definitely the facing. We need pictures there. And then on the interior, we need screenshots of the different simulations you ran. Anytime you make a change, it should be very briefly, it should be simple to say what's changed. That's both inside and outside. So you're collecting your data, you're putting it in a spreadsheet, you're doing whatever, if there's any calculations like dividing one by the other to get a percent difference in terms of what changed by making some change. And then I want you to analyze that. So you've done the work, number 1 and 2. Number 3, you're collecting your data together and organizing it in a way that, remember, when you're collecting data, you're not doing it to show somebody else. You're doing it first and foremost to show yourself. So you're learning what you want to do with it, how you want to change your design or whatever your goal is. And then to do that, you need to analyze the data. So then I want you to look at the data and just make some kind of comment about what you're seeing there. And then you're submitting all that as a PDF, as we've been typically doing. That's just the exercise for this week. All right, see you in class.